Okay, in this lesson we're going to practice a couple different applications of basic probability distributions. So remember, in each of these we're going to be asked to find the expected value, which means we are looking for the average outcome. Now the issue with each of these is we don't have the probability distribution organized for us in a table like we did in our previous examples. So you're going to have to read and organize that. It's helpful to organize it. In this first one, at a raffle, 1,500 tickets are sold at $2 each for four prizes of $500, $250, $150, and $75. You buy one ticket. What is the expected value of your gain or loss? Okay, I'm just listing the events here to kind of keep us organized. We're not actually going to calculate with this, but it helps us get started. So we're going to look at each of the events in our sample space. It could be that we win $500. It could be that we win 250, win 150, or win 75, or more likely lose and win 0. Our values here could be a gain or a loss, so I should have written gain or loss here. If we win $500, we actually are gaining only $498 because we have to take away the cost of the ticket that we used to purchase the ticket. So these gain or losses could be listed by taking $2 away from each of these values here. So after that, we're not really calculating with this first column. This is the true value of each of our outcomes. Okay, then we need to take a look at the probability of each of these outcomes. The probability of winning that $500 is one ticket out of the 1,500 tickets sold. Same thing for the next three weights or probabilities here. And then that last probability, the probability of losing $2, well, if we have 4 winning tickets out of the 1,500, we're going to have 1,496 losing tickets. And so I could divide that by $1,500. Now, you would probably want to put in decimal values for each of these. I just left them in fraction form because I wanted you to see where they all came from. Okay, so our last column is created by multiplying the value of each outcome with the probability to get this final value here. And each of these values in our last column alone really do not make a whole lot of sense. They have very little meaning, but the last step is to add this final column to find our expected value. So when we do that, we come up with a negative 1.35. So basically what that means is the average ticket buyer loses $1.35. So in the case of this raffle, the average outcome is a loss of $1.35. In a sense, the winnings are distributed across all 1,500 ticket holders to arrive at that expected value of negative 135. Now it seems like an odd way to think about probability of gambling, but in general this method is applied to business ventures to calculate the risk of loss or the likelihood of gain in an investment. So that concept comes into play there. Okay, our next one we're going to be taking, I can slide it all the way up here, we're going to be looking at a life insurance scenario. A 30-year-old male has a 9,986 10,000th chance, I prefer to look at it as a probability, or as a percentage, a 99.86% or probability of living throughout the year. So very little chance of dropping. Okay, he purchases $100,000 worth of life insurance at a coverage for $161 per year. What is the expected value of such a policy for a year? Okay, so again, we're going to organize our probability distribution. And again, this one's actually going to be pretty easy because we only have 2 events. Either he lives or he dies. Okay, so that event column is just to help us get organized and get started. The value of living is he's going to be out the $161 that he spent on the policy. The value of dying is the $99,839 that his beneficiary gains should he die. The probability of living is actually given to us in our problem. And because we only have 2 possible events in this, we can use the complement rule to find the probability of actually dying, which is quite small. Again, for our final column, we're going to multiply the value of each event times its probability. and then our final column we're going to add up. So we have an expected value. This averages out to a negative $21 is the expected value. And basically what you're doing is you are, a way to look at it is for all the policies of 30-year-old males, the payout for the few that die is averaged across all such policies. And that is this expected value of negative $21. That's going to have meaning in the financial world of insurance. They would rank and rate all of their policies based on this expected value. So for us it doesn't have a whole lot of meaning, but in that insurance world it really does. Okay, back to gambling. In the Illinois Pick 3 lottery, you pay 50 cents to select a sequence of 3 digits and pay $250 if your sequence matches the sequence drawn. We have a series of questions that we need to answer here. What is the probability of winning? And if you win, what is the net profit? And what is the expected value? So being we're into expected value, I'm kind of getting started with setting up a probability distribution. So again, we have 2 different events, win or lose. The outcome or the value of winning is $250. The value of losing is you're out 50 cents. Now this probability piece here, they didn't give us any probability in here. We're going to have to figure this out. So if we look at this, we have a sequence of 3 digits. We need to remember our fundamental counting rule, or the principle, fundamental counting principle, and recognize that when we have 3 different digits like this, we have 3 different options here, each of them having 10 different possibilities, a digit of 0 through 9. And so when we multiply all these together, we find that we have 1,000 possible tickets or sequences. Any one of those being the one that's drawn would be a 1,000th. I think I have one extra 0 in here. I need to erase that. So I put this probability in here of 1,000th goes with the probability, the outcome of winning, and the complement goes with the probability or the value of being out 50 cents. So we take the product of these two to come up with our final column, and again by themselves they don't make a whole lot of sense, but we looked at the expected value of summing these two. On average, the average person is going to be out 25 cents. Okay, the thing that's kind of sweet about this is we can do all of this on StatCrunch. So I opened StatCrunch here, and on our first problem, and the first column in StatCrunch, I put in our adjusted values for each of our events, and then the probabilities for each of those events in decimal form. If you are doing this, and you will be doing this in your homework, in my math lab, you're going to see that you have a little, like a little rectangle near your problem in my math lab, that if you click on that, it will automatically open your problem up in StatCrunch. So hopefully I'll get a chance to demonstrate that. But on this one, I had to enter all the values. Okay, so once I have the values in here, what you need to do, it's very slick. You just go to Stats, which is the third to the last tab there. I'm going to use Calculators, which is our first option, and all the way down to Custom. So I'm going to show you that again. We're going to go to Stat, Calculators, over and down all the way to Custom. Okay, so once I'm in Custom, I need to identify where are my values and where are my weights or probabilities. So I'm going to do the drop down. My values are in var 1. My weights or probabilities are in var 2. And all I need to do is click Compute, and StatCrunch does it all for me. It's trying to show us a histogram here, but our probabilities are so low on those remaining 4 that nothing shows up here. But what's important to you is looking at the mean here. That's all we care about in this particular one, is the mean. Is our mean is a negative 1.3499, which would round up to our negative 1.35, which is what we got in our problem. So it's kind of sweet that we can do this all in StatCrunch. So I guess I'll show you one more time. The same problem. In any of your problems, you're going to go to Calculators, Stats, Calculators, all the way down to Custom. Identify. Usually it's the same order. The weights, the values are in var 1, weights are in var 2, and then you click Compute. And you go, sweet, there's your answer there with mean. And that's all she wrote for this one.